Today, there are amazing three-dimensional imaging solutions for the forensic sciences, especially because of the new Edge 3D microscope. Why does one need a 3D microscope? In order to acquire the hidden depth information that exists within the samples being investigated. This allows us to collect more accurate data. This additional information will decrease misdiagnoses and increase productivity. Another reason forensic scientists need 3D is that real-world evidence is naturally three-dimensional. Things like bullet analysis, tool markings, trace evidence, document analysis, fabric identification, counterfeits, forgeries, and biological specimens. These samples are all naturally three-dimensional. To be able to examine specimens in 3D without destroying the evidence by cutting sections gives the observer a tremendous advantage. Let's look at the shell casing of a bullet with the Edge 3D microscope. This is a conventional two-dimensional image of the end of the bullet casing, and as we can see, only a small portion of the image is in focus. Compare that with the full focus image that is produced by the Edge 3D microscope. The addition of the color-coded depth image allows one to quantify the exact shape that the firing pin produced in the shell casing when the bullet was fired. It shows there is a depth of 750 microns from the top to the bottom. The bottom of the pit is 0, as shown in blue, and the highest point is shown in red. The depth information can be easily visualized by turning the image into a 3D model. These 3D models can be viewed at any chosen angle. The depth information can also be visualized by producing 3D video loops. Here is a closer two-dimensional view of the firing pin markings. We see that only a small portion of the markings are in focus. Now, with the Edge 3D microscope, we see a full-focus reconstruction of the markings throughout the entire depth of the firing pin impression. Now, with the addition of the color-coded depth information, the unique signature of this firing pin can be precisely quantified. Here is a three-dimensional video of the firing pin impression that was made using a different gun. Each firing pin of each gun produces a characteristic shape. And here is the color depth map that corresponds to this particular firing pin. Here are the depth maps produced by the firing pins of 4 different guns. We can see that each firing pin produces a unique depth map signature. Here is a two-dimensional image of a tool marking in a piece of metal, and as we can see, only a small portion of the image is in focus. And now, with the Edge 3D microscope, the entire tool marking is seen in full focus. This tool marking can be precisely quantified by analyzing the calibrated 3D color depth image. And here, the depth information is visualized by using a 3D rotational video loop. Document analysis is an important area of forensic science to determine forgeries and counterfeits. Here is a two-dimensional image of 2 strokes of a ballpoint pen on paper. Here is a full focus image of the 2 strokes of the pen. The question is, which stroke was created first? A 3D model shows that the pen strokes create tiny grooves in the paper. The 3D model indicates that the horizontal line was drawn after the vertical line. The addition of the color-coded depth image verifies that this is true. We see this because the horizontal line created the continuous groove, whereas the groove in the vertical line was interrupted by the horizontal line. This positively confirms that the horizontal line was drawn after the vertical line. This is a picture of the microprinting on the end of a $100 bill that says USA, USA, USA. We can see a blue security fiber on the top portion of the image. Here is a closer two-dimensional view of the microprinting, and we see that only a portion of the image is in focus. This 3D video loop of the microprinting shows the three-dimensional nature of the microprinting. And here is a closer view of the 3D printing. The Edge 3D research microscope shown on the left produced the images shown in this presentation. Edge is excited to announce that the Mark II version seen on the right will be introduced in February of 2018. For more information, contact the link shown below. Thank you.